Our second test of hypothesis here for proportions tells us a newspaper editor wants to determine whether her staff is making too many typos that go to print. The paper is willing to allow 3% of their final editions to have typos. The editor examines the last 365 that have been put out and finds that there were 18 with typos. Conduct a test of hypothesis to see if more than 3% of typos at the 99% level of confidence. First step, I need to create a null and alternative. So here it says that we're doing a test of hypothesis to see if more than 3% have typos. So we're testing that p is greater than 0.03. That means our null is p equals 0.03. Now that we have our null and alternative, let's pull out the key information that we have. We already know that 0.03 is the p under the null. Here we find that our n sample size that we're looking at is 365 papers. Of them, we find that x, the number of typos, equals 18. That allows us to calculate p hat as 18 over 365. When I put that into my calculator, 18 divided by 365 gives me 0.04931. I recommend keeping at least two significant digits, so I'm going to call this 0.049. When I say two significant digits, I mean two numbers beyond where you get your first number. So this 0 doesn't count. Here's a significant digit. I want one more. If you'd rounded this to 0.05, that wouldn't be wrong necessarily, but there could be times, especially when it's these smaller numbers, where you don't want to round too much and lose information. Now that I have all this, I just need to see the confidence level that they asked for. They asked for C equals 0.99 or 99% confidence. I can leave it there and deal with it later, but I like to find alpha at this point. So I'm going to do 1 minus the confidence level, or 1 minus 0.99 to get 0.01, which is my alpha that I'll eventually compare to. When I go to find the test statistic, my test statistic should be based off of z equals p hat 0.049 minus the p under the null hypothesis 0.03 divided by the root of p under the null hypothesis 0.03 times 1 minus that 0.03 over my n of 365. Again, where students get messed up the most on this problem is getting this entered into the calculator correctly, particularly this bottom, making sure that your root sign has everything going on underneath it. So if I put this into my calculator, I should put it in as parentheses 0.049 minus 0.03 n parentheses divided by new parentheses the root of parentheses 0.03 n parentheses new parentheses 1 minus 0.03 n parentheses divided by 365 n parentheses. All of that should get me to 2.127, which I'm going to call 2.13. I then need to go to the positive side of my table. On the positive side, 2.13 maps to a p-value of 0.9834. So this is my correct step 2 test statistic. Here, this p-value from the table, I'm going to need to adjust to find the test probability. What I'm going to need to look at is the alternative hypothesis. Because this is a greater than alternative hypothesis, I'm looking for a right-sided value. So I'm going to do 1 minus this table p-value. If I do 1 minus 0.9834, that's going to give me 0.0166. Now that I have a test probability, I'm going to take that test probability, 0.0166. I'm going to compare it to my alpha, which again I found by doing 1 minus confidence level of 0.01. In this case, 0.0166 is larger than 0.01. When your test probability is bigger than your alpha, you fail to reject the null.